Assalamu alaikum. So we'll start with another topic which is called as contouring. So in order to give an introduction to this topic, I'll just go straight to a contour map. So basically contouring is a process that allows us to create maps which look something like this. And these maps are called as contour maps. And what these maps actually depict are series of lines that join each other, and usually they form a loop. And these lines show elevation of ground surface. So contour lines are the lines which join the points of equal elevation. So that means if you show an area with a map like this, any point on this specific line will have the same reduced level. Similarly, any point on this specific line will have the same reduced level. And by having a map that shows lines of different reduced levels and they constitute a map, so you can guess about or know for sure about the shape of the land, or how the topography of the land changes, or how the slope of the land changes. So it gives you a clear picture of reduced levels of different points on the ground, and hence gives you a picture about what the land looks like, what side of the lands are at a higher elevation, which sides are at a lower elevation, if there are any valleys in the land, if there are mountains, how many mountains are there, what sort of a topography is there. So you can get everything by just looking at this map. So if you look at this picture over here, so this picture on the lower half, uh, this shows a section of the ground. So this means that there are two hills that you see over here, and when the same section or the same area of the ground is shown in a plan view with the contour map, so you see that these loops show that there are two hills over here. So in a contour map, in addition to these lines, what is important for you to show on the map is these reduced levels. So these values that you see along every line, these show the reduced levels. So this means that every point on this circle or this loop has a reduced level of 50. Similarly, every point on this line has a reduced level of 10, and hence we have two peaks over here. So we have two circles. This peak is at a lower elevation than this peak. That is why over here we have a contour of 50, the highest contour of 50, and over here the highest contour is of 40. So since these pictures, the lower picture is shown in section, so you see it from the front, and this picture is showing you the plan view. So this is seen from the top. So you see this complete loop. That means that we have a conical shape over here, which is usually the shape of a peak. So if you want to draw a contour map of this peak, that would mean uh, every point along this circumference or along this cone would have the same elevation. As you go down, the elevation would keep on decreasing, but the size of the loop would keep on increasing because that is what the shape of the peak shows you. In addition, your contour map can tell you a lot of different things. So if you see this diagram over here, that's a more that's covering more area. So you can see that again we have these complete loops, and the centermost loop has the highest elevation, and as you go down from there or away from there, the values on the contour map decrease. That means the elevation is most at the center, and the area for the elevated point is lesser, or the circumference is lesser, and as you go down, it keeps on increasing. So this tells you a picture that this is part of a hill. So that's one thing. Another thing to see over here is that the distance between the contour lines can change. And if the distance between the contour lines is more, that means that the area is relatively flatter, or the slope does not change at a greater rate. And if the contour lines are very close to each other, that means that um, the slope is very steep, or the elevation is changing very steeply. So it gives us a complete picture of what the land looks like. So let's see the definitions. A contour is defined as an imaginary line that joins points of equal height above sea level. So whenever you follow one single contour line, wherever it goes, that means the elevation along this line or of all the points on this line is the same. So, for example, the watermarks made by water of a still pond or lake with the surrounding ground represents a contour line. So, as the ripples emerge in water, or if you might have observed in a dam where when the water level is down, so you can see watermarks all along the valley. And since the water has a distinct elevation and the water keeps its level, so that ring gives you that all the points on that ring or that mark have the same elevation. And as the water level keeps on changing, so that will those marks will keep on going down or going up. Similarly, if you throw a stone in water, the ripples that form, they also take the form of a contour. So the lines are numbered, giving the height above sea level in meters, and or it can be in feet. It is not a rule that it has to be in meters. And contour lines can be used to learn about the shape of the land. We discussed that. A map with few contours means that the area is flat, because if the the contour lines that are drawn have a contour interval, that means if the first contour that I'm drawing is for 50 and the next is for 40, next is for 30, I can change it. I can draw it for 50 and 45 and 40 and then 35 and then 30. So that depends. But if the area is deeper, then it means that the contour lines will be very close to each other. Or I don't have to choose um, a very big contour interval. And if the area is flat, that means these values won't change very quickly. So that means if it's 50 over here, then 40 would be far away from here, right? So it depends on how the slope changes. More contour lines mean that the area is hilly or mountainous. So we've discussed that because the slope changes very abruptly. And if the contour lines are closely spaced, it means that the ground is steeper. Let's see over here. This picture represents it very accurately. That now we have a hill. So, and if you take elevations along this part of the hill and you would draw this contour over here. So let's say this is for 60. So all the points along this circumference along the hill, so on all sides, that makes up a line of 60. Then if you do it over here, so all the points along this are at 50, and see that the perimeter keeps on increasing because it's a conical shape, and at the top the perimeter is smallest. So that's why this loop is very not very wide, or the diameter is not too much. And as you keep on going down, the perimeter keeps getting more because this 10 meters is all along this part of the hill. So as the base keeps on expanding, so that means the perimeter would keep on getting more. Another thing to see over here, which is interesting, is that this side of the hill has a milder slope and this side of the hill has a steeper slope. So that means that the contours along this side will be closely spaced, will be more close to each other. And the contours on this side, where the slope is milder, the contours will be more spaced away from each other, or the space between two lines, two consecutive contours would be more. Whereas where the slope changes abruptly, the space between two contours will be smaller. So the contour line is not tell you how the topography changes, and also tell you about how abruptly or how slowly the slope is changing. So it is an imaginary line joining points of the same reduced level on the surface of the earth. And yeah, so we've discussed what's written over here. So contouring means the method of taking measurements or reduced levels in the field and drawing contour maps. So in order to draw the contour maps, first step is to take levels in the field. And you can do that by the methods that we have discussed in this course, or some other methods that you'll study in the next course, which are quicker. But in order to draw these maps, you need to know reduced levels of a lot of points on the ground. so that you can come up with this map. So a contour map or a topographic map depicts the undulations or relief in the form of a contour. So undulations means how the ground elevations are changing, and relief basically means the same thing, and it gives a complete picture of the Earth's surface. So once you have this map, you get a clear picture of the properties of the land, and then it helps you a lot in deciding on what projects are suitable for that land, or if you have a specific project in mind, if that land is suitable for that project or not. So these maps are very helpful. So this is what a topographic map looks like. Contour lines are the distinguishing feature on a topographic map, and the contour lines show shape and elevation of the terrain. And closely spaced contour lines represent steep slopes. If the contours are widely spaced, then the terrain is relatively flat. So as you can see over here, if you want to represent uh, this part of a hill on a contour map, so as you can see that the slope along this line is changing very quickly. That's why the contours along this line are very close. And on the other sides, the slope is milder, so the space between the contours is more. So this is how a contour is actually built. And since sometimes the lines can be very close to each other, and it's not possible for you to write down the elevation of every line. So in this case, if this is 300, this is 250, and this is 200, so you can write 290, 280, 70, 60, 50, and so on, but it makes the whole map very crowded. So, and since the contour interval, that means the interval between which you are making your contours, which in this case is 10. So that remains the same. So you don't have to write the elevation for every point. So the reader can judge it, and for those lines whose contour or elevation level you write down, so those contour lines are called as index contours, and they are shown by a bolder line, while the other lines whose elevation is not mentioned on the map are shown by uh, less bold lines, and the number is not written. So these all of them are contour lines, basically the same thing. And this is the contour interval. That means what is the difference between the elevation between two specific contours. And this elevation can be anything. It depends on what sort of project you are doing, how much should be the difference between the elevations, or what is the nature of the land. It depends on a lot of things. Basically, if I try to make contour lines for smaller contour intervals, the work that I have to do in the field will increase a lot. So that is why a lot of factors are kept in mind before deciding on the contour interval. So topographic maps render the 3D ups and downs of the terrain on a two-dimensional surface. So the undulations incorporated into a map give you a 3D look, but that is shown on a 2D map. So that is one benefit of it. Topographic maps usually portray both natural and man-made features. So it doesn't have to be just for the natural features. You can also depict man-made features as well. And they show and name works of nature, including mountains, valleys, plains, lakes, rivers, and vegetation. They also identify the principal works of man, such as roads, boundaries, transmission lines, and major buildings. So you can show those as well. So basically, you get idea about the entire nature of the land that we are talking about by looking at these maps. And also, there's a feature on Google Maps on which you can turn on the terrain, and it can show you these inbuilt contour maps of any land that you want. And similarly, you can see it on Google Earth as well. Even on Google Earth, you can use the software to draw these contours by selecting different points, and by suggesting a contour interval, you can draw these contours as well. So let's try to match these contour lines by the respective sections. So these are sections of different lands, and we need to match them by their respective contour maps. So the first thing that you can do is to see if there are two peaks. That means there would be two loops in the center, and if there is just one peak, so that means you will have a contour map which looks something like this. So let's start with the easiest one. So let's start with E. E has a relatively similar slope on both sides, and at the center we have the peak, and so the relative respective contour map should have a circle in the center and relatively similar uh, spacing between the contour lines on the left side and the right side. So this second contour map basically reflects this section E. Similarly, let's talk about F. So if you see this section, it has a relatively milder slope on this side, and at the top it becomes flat. So if it is flatter at the top, that means that the contour line would be very far spaced over here, and the spacing between the contours would be smaller than whatever the spacing is over here. So over here you will have basically a blank picture with one contour along the perimeter. So if you see over here on this map 5, that pretty much goes along with it. So you have on this side a flatter surface, that's why a bigger loop, and the slope is steeper over here. So the contour lines are very close on this side, and the slope is very mild over here. That is why the distance between the contour lines is bigger on this side. So this is how basically you decide on or you can get a picture by looking at these maps that what sort of a land are we talking about. So you can do the rest of them and basically follow the same principles. So the rules for drawing the contour lines, every point on a contour line is of the exact same elevation, that is contour lines connect points of equal elevation. So whenever you have a contour map, the lines, every point on each line has the same elevation. So that's rule number one. Contour lines always separate points of higher elevation from points of lower elevation, so uphill points from the downhill points, and you must determine which direction on the map is higher and which is lower relative to the contour line in question by checking the adjacent elevation. So when you have a contour map, you should refer to the index contours, and they would tell you if at the center the elevation is more or along the other side elevation is more, because up till now we've talked about contours by saying that the center is usually the point or the location where the elevation is the highest. But it can be the case that in this contour, if I write 500, 400, 300, 200, 100 over here, that means instead of this being a hill, it's a valley. Because at the center, the elevation is lowest, and as you go uh, towards the sides, the elevation keeps on increasing. That means this is a valley. So you need to see what the contour index contours tell you, how the elevation is changing as you move along the contour map, and that is how you get a picture of what the ground is like. Contour lines always close to form an irregular circle, but sometimes part of contour lines extend beyond the mapped area so that you cannot see the entire circle formed, and this is very important. Whenever you see a contour map, so yeah, let's see this one. Usually we only draw the contour map for the area which is in question. That means the area which is relevant to us. Otherwise, the whole work gets very lengthy. And since we draw it just for that area, uh, your contour lines might not form a complete irregular circle, or they might not form a loop. But the rule is that whenever you draw a contour map for a complete area or for a broader area, these lines always merge or they form circles. So if you see this map over here, all these contour lines should form irregular circles. But if on your map the lines do not form a part of a circle, that means the mapped area on which you are drawing the contours is smaller. If you draw it for a bigger area, these lines will end up becoming part of a bigger irregular circle. So that's the rule. The elevation between any two adjacent contour lines of different elevation on a topographic map is the contour interval. So something that we discussed before, what contour interval is. Often every fifth contour line is heavier, so that you can count by 5 times the contour interval. So like we discussed, that we have index contours. on which you can write down what the elevation is, and then you can count what should be the elevation for the other lines until you reach the next index contour. And since the contour interval remains the same on a map, that's very important. The contour interval is fixed once and it remains same throughout the map. So you can then judge by yourself which elevation a particular contour line is depicted. Contour lines never cross one another except for one rare case when an overhanging cliff is present. In such a case, the hidden contours are dashed. So one other rule is that the contour lines never cross each other. So they form irregular circles and they never intersect each other. But there is just one condition or one case where they will intersect each other, and that is in the case of an overhanging cliff. So let's see what an overhanging cliff is. So it's something like this. So if you can see over here at the same section, if I draw a section in the plan, different points have different elevations, but that's not the case everywhere else. So at everywhere else, every point has just one elevation, but over here at the same section, if I draw a 2D map at the same location on the map, x-axis, you have points with different elevations. That is why only in the case of overhanging cliffs, a contour line can intersect each other. And in that case, uh, this is again an overhanging cliff. So you have land profile that looks something like this. So if you draw a section over here, so this section has points with different elevations. So in that case, uh, we intersect the contours. So you can see this intersection over here, and the line with the lower elevation is shown by dashed lines, and the one with the bigger elevation, higher elevation, is shown by a solid line. So contour lines can merge to form a single contour line only when there is a vertical cliff. So these are two cases which are very different from regular contour maps, and they can only arise if one, you have an overhanging cliff, or two, you have a vertical cliff. Now a vertical cliff is different from an overhanging cliff uh, because in a vertical cliff you have this sort of a topography where it just goes vertically down. So in this case, we have contour lines of different elevations coming together, and at this junction, they form one line. And whenever you see something like this, that means it is a vertical cliff. And the other condition is that when they intersect, that is an overhanging cliff. So these are just two rare examples. Otherwise, the rules that we have said before, all of them apply. Evenly spaced contour lines of different elevations represent a uniform slope. So if you have contour lines that have equal distance between them, since the contour lines are showing you points of different elevation, and if they are evenly spaced and the contour interval is same, that means that the land has a uniform slope. Otherwise, when the distance between them changes, that means the slope keeps on changing as you move along whatever land feature it is. The closer the contour lines to one another, the steeper the slope. We discussed that. In other words, steeper the slope, the closer the contour line. So we discussed that. A concentric series of closed contours represents a hill. Again, we've seen it. And depression contours have hatchet marks on the downhill side and present a closed depression. Um, Usually, when you want to show the same thing, so over here, the closely spaced concentric circles show a hill. Over here, they show a valley, and you can show them with these markings. So it would tell you that this is something in depression. But usually, since you write down the elevations along the index contours, you don't have to do this, and you usually won't see this in contour maps. But this is one way you can represent if you are not writing down the contour elevations. Contour lines form a V pattern when crossing streams, and the apex of the V always points upstream. So, whenever you have a shape like this where different contour lines make this sort of a pattern piece, and whenever you see something like this, that means this is going through a valley, and going through a valley is usually a river. So this means this shows the path of a stream. And contour lines that occur on opposite sides of a valley always occur in pair, so as seen over here. And topographic maps published by the US Geological Survey are contoured in feet or meters, reference to the sea level. So we discussed why in an overhanging cliff you have contours that intersect each other, and this is what overhanging cliffs look like. Again, we have a couple of examples for the contour maps, and we've seen what's the difference between a vertical cliff and an overhanging cliff and how the contours change. So steepness of surface is represented by closeness of contours. So if you see this contour map for this area, if you don't have these lines, that's just a picture taken from the satellite, and it doesn't tell you much about how the elevations are changing because it is taken from the top, and from the top it's difficult for you to judge the elevation of the land. So that is why on the same picture taken by the satellite, we introduce these contour lines or contour marks that can give 3D picture of the same area. So now that we have the contour lines, you can see that since this forms a concentric series of concentric circles, so we have a summit. Over here, summit is the highest point on the hill. So over here we have a hill, and this is the highest point. And as you go towards this side, the slope changes slightly, and as you go down from this side, the slope changes more steeply. So over here we have gentle slope, and over here we have steep slope. So now we see what's a ridge line and a valley line. So if you're standing on the center line of a ridge, you will normally have high ground in one direction and low ground in other three directions with varying degrees of slope. If you cross a ridge at right angles, you will climb steeply to the crest and then descend steeply to the base. And when you move along the path of the ridge, there may either be an unnoticeable slope or a very obvious incline. So let's see this picture to understand what a ridge is. So ridge is basically the top line of a series of hills. So if you move along this ridge, so you have higher ground on one side and then lower ground on the other three sides. So if you go left or right, you will be going down, and if you go straight, you will be going up, or in one direction you'll be going up, in the other direction you'll be going down. But if you cross it at 90 degrees, that means you are crossing the top line of a series of hills. And one you go up, then there will be a little bit flatter ground, and then you will descend towards the other side. So this thing is represented on a contour by these three series of concentric circles. So that means in the centers we have three hills. Otherwise, we have the land which is at the same gradient, joining all these three hills. So if you have a contour map that's something like this, so this shows you that this is a ridge, and this ridge line on a contour is shown by a series of different concentric circles in a straight line. So that is basically a ridge line. Similarly, a valley line, like we discussed before, V-shaped curves having convex side towards higher elevations. So whenever you have a valley line, that means you have elevations changing and the slope is changing towards one side, and they give you a picture of a valley. So this is a characteristic of a contour. If you get a shape like this in a contour map, that means it's a valley. So again, ridge and valley lines. So a ridge looks something like this, and a valley has depression along the same line. So now let's discuss some important characteristics of contours. I have discussed some of them. Contour interval is the vertical difference in elevation between two contours. So contour interval is not the horizontal distance. It is the vertical difference which you have chosen in the beginning to draw your contour maps. So the contour interval remains constant for a particular contour map. So once you've chosen that, you cannot change it for different parts of the land. And following factors are to be considered when deciding the contour interval, because this is the most important factor that you have to decide, because it really increases or reduces the amount of work that you have to do. And depending on the purpose of the map or the project, it might not serve the purpose if you take a wrong contour interval. So the factors on which this depends is one, the purpose of the map, nature of the ground, scale of the map, time and funds available, and extent of survey. So let's discuss them one by one. Purpose of map or extent of survey. So contour interval should be small enough to serve the intended purpose. So that means if you choose a big contour interval, so let's say I choose a contour interval of 20 meters. So that means I'll be missing a lot of features of the land if I am choosing such a big contour interval. And choosing a big contour interval might not serve the purpose for which I am drawing the map. On the other hand, a very small contour interval results in costly survey. So you have to balance the cost and benefit, what the purpose of the map is, and how much am I willing to spend on the map. Because if I choose a small contour interval, so as compared to 20 meters, if I choose a contour interval to be 2 meters, that means the amount of work that I'll have to do will be a lot. However, for detailed work, small contour interval is preferable. If you choose a small contour interval, that means you would be leaving out very little information for the land, and large contour interval for rough mapping meant for initial assessment. So for reconnaissance survey, for initial assessment, large contour interval should suffice, but for detailed calculations such as finding out the volume of a valley, uh, so that means you need detailed work. Then nature of the ground. So if you have a flat ground, you will choose a small contour interval. That is because since the land is flat, if you choose a large contour interval, so that means on very large part of the land you would have just one line, because the slope is not changing. It's a flat ground. So to get some meaningful results on a flat ground, you need to choose a small contour interval, so that by looking at the map you'll get some sense out of it. And for steep slopes, you'll choose a large contour interval, because if you choose a small contour interval, you'll have so many contour lines which are very close to each other. Since uh, the distance does not change much horizontally, and the vertical elevation changes quickly. So if you choose a very small contour interval, you'll have so many lines packed together, and again, it would be very hard to make sense of that contour map. Then we have scale of map. If the scale is small, then contour interval is kept large, so that the contours found are not congested. So that means on a small scale map, small contour intervals will be difficult to show. But if the scale of the map is large, that means even small contour interval lines can be visible. Type of survey for detailed design of buildings. So, like we discussed before, the more details you want, the smaller will be the contour interval, and the lesser details you want, the rougher you want it to be, you'll choose a larger contour interval. Time and funds. Again, smaller contour interval means more time will be required and more resources will be required. And for larger contour intervals, you will need lesser time and lesser funds.